Imagine this: our planet, Earth, is spinning right now. It is in continuous motion through space. We do not feel this motion, so we often take it for granted. But if that rotation suddenly stops, the entire world would become a place of complete, immediate chaos. To understand the sheer magnitude of this catastrophe, we first need to appreciate how fast we are truly moving along with the planet. This depends on where you stand. If you stand right at one of the poles, you are spinning but essentially staying stationary with respect to the center of the Earth. However, if you stand near the equator, your linear speed is around 1,000 miles per hour. Think about that speed for a moment. 1,000 miles per hour is faster than the speed of sound itself. This rotational velocity is why many rockets are launched toward the east. They get a boost from Earth's natural spin. This spinning motion has existed since the Earth first formed. Before the planets existed, our solar system began as a large, revolving cloud of dust. As dust particles crashed into each other and stuck together, forming larger rocks, and eventually planets through a process called accretion, the cloud's initial spinning motion was conserved. This conserved momentum is what keeps the planet spinning constantly, even today. Now picture that instantaneous stop. What happens in the first 1 second after rotation ceases? The foundational principle here is simple physics, Newton's first law of motion. This law states that an object continues in its existing state of motion unless an outside force acts upon it. Everything on the surface, the air, the water, all the buildings and every person, animal and car was moving eastward at that 1,000 miles per hour equatorial speed just 1 moment before. When the solid ground stops instantly, the sudden lack of friction means everything not attached to the core continues moving eastward due to inertia. Near the equator, this means virtually everything would be ripped off the surface and thrown sideways at supersonic speeds. This immediate event would initiate an unimaginable wave of destruction across the globe. The immediate inertia effect is so overwhelming that it would set the stage for total failure across almost all planetary systems. The material that was rotating along with the Earth, the water, the air, the structures, and all living things would be forced to keep going due to their prior momentum. They would split off the surface and just keep going around and around, basically, in a low orbit around the Earth, according to physicists. This is a planetary-scale collision where the ground is suddenly stationary, but everything on top of it is moving at orbital velocity. Only regions at or very close to the poles would experience minimal impact from this inertial force, since those areas rotate little or not at all. However, even near the poles, the extreme forces exerted across the entire planet during this impossible deceleration would likely still trigger widespread seismic activity. In that first instant, the physical force tearing things apart would be beyond comprehension. Every structure built by humans and every living thing caught in that abrupt stop would face immediate and complete obliteration. Let's focus entirely on the consequences of the 1,000 miles per hour inertia effect. This initial, instantaneous event determines the fate of everything from the air we breathe to the deepest infrastructure. We established that near the equator, things are moving at approximately 1,000 miles per hour, or 1,600 kilometers per hour. This speed is maintained by all unattached mass when the Earth's rotation abruptly ceases. The result is pure, unmitigated kinetic energy, instantly translating into global damage. Imagine standing still while a wind blows past you at the speed of sound, but that wind is not just air. It is the ground ripping away, buildings shearing off their foundations, and the atmosphere attempting to peel itself from the crust. Buildings, bridges, and infrastructure would be wiped out immediately. The materials they are made of cannot withstand the sudden force difference. Walls would instantly disintegrate as the ground beneath them stops, while the materials retain their original, high-speed eastward momentum. The destruction would be universal and total for almost every man-made structure. For animals and humans, the situation is even more direct. Because everything not firmly connected to the solid crust continues moving at its rotational speed, living organisms would be thrown eastward. Near the equator, this throws animals and people sideways at over 1,000 miles per hour. This catastrophic action launches biological material off the surface and into the air. The only areas that experience less initial destruction are near the poles. Near the North and South poles, the linear speed of rotation is close to zero or minimal at most. This means that objects in these regions would not experience the same extreme sideways violence that equatorial zones would. For example, the plane journey mentioned in the sources highlights that motion relative to the center of the Earth drops off dramatically as you approach the poles. However, even if the inertial force near the poles is minimized, the sheer energy transferred across the globe would cause massive physical disruptions. The momentum transfer across the planet would trigger immense tsunamis and earthquakes. Therefore, relying on polar stability for survival is a false hope. The entire Earth experiences disastrous events. This inertia effect sets the stage for the secondary disasters. The immediate destruction, everything flying eastward in a planetary demolition event, leads directly to the atmospheric collapse and the sloshing of the oceans. The instantaneous stop ensures that the environment is catastrophically disrupted before any long-term effects can even begin to set in. The conservation of momentum, which once allowed the planet to form and spin, now becomes the engine of its destruction. Following the initial inertia, the atmosphere itself becomes a weapon, leading to global megawinds and atmospheric collapse. The air and ocean currents that govern our normal weather systems are profoundly influenced by the Earth's rotation. When that rotation stops, those currents and the air itself do not. Just like physical objects, the atmosphere holds its momentum. If the solid ground suddenly stops, the entire body of air around the Earth continues to sweep eastward at the speed it had been traveling, up to 1,000 miles per hour near the equator. This generates sustained, supersonic gales that scour the surface. Physicist Andrew Layden notes that air currents are strongly influenced by rotation. Once rotation is lost, the entire system of atmospheric movement is disrupted. The immense speed difference between the stationary ground and the moving air results in a massive shear effect. If the air continues moving at 1,000 miles per hour while hitting mountains and continental plateaus that are suddenly still, the resulting friction and force would be immense. These megawinds would not be like hurricanes or tornadoes. They would be a persistent, planet-wide shearing action that rips apart the remaining surface features. Any debris or infrastructure not destroyed in the initial second would be subject to this perpetual, high-speed atmospheric erosion. The forces generated would be so extreme that they would act to effectively strip away and drastically change the structure of the atmosphere itself. We see how crucial rotation is by observing existing phenomena such as the Coriolis effect. The Coriolis effect is an interesting phenomenon created by the difference in linear speeds between the poles and the equator. It makes objects traveling large distances, like a plane heading from the equator toward the North Pole, appear to curve relative to the Earth's surface because the plane retains the faster lateral speed of the equator as it moves toward the slower polar regions. This effect plays a key role in setting up the planet's normal air and water currents. When rotation stops, the Coriolis effect vanishes, contributing to the instability and extreme nature of the new stationary weather patterns. Even before the spin stops, phenomena like weather systems apply forces to the Earth's surface. Strong winds contribute to changing the planet's rotation rate, demonstrating the powerful interaction between the atmosphere and the solid planet. When the Earth stops, that massive 1,000 miles per hour airflow slams into a stationary planet, transferring unimaginable energy that contributes to global disaster. The consequences include not only total surface demolition, but also severe, continuing climate disruption because air and ocean circulation systems are fundamentally dependent on planetary rotation. The consequences of the rotational stop extend immediately to the planet's water bodies, creating massive super tsunamis that would fundamentally reshape the global map. The Earth's current shape is not a perfect sphere. Rotation plays a physical role in making the planet bulge outward around the equator. This equatorial bulge exists because of centrifugal force generated by the spinning Earth. This bulge holds a significant amount of the world's oceans in place along the middle of the globe. If rotation were to cease, this centrifugal force would disappear instantly. The gravitational forces would then immediately begin working to pull the planet, and specifically the loose water mass, into a new shape, a perfect non-rotating sphere. Without the rotational force to hold the water against the equator, all the excess oceanic water previously held there would rush violently toward the poles. This catastrophic redistribution of water would unleash gigantic tsunamis across the planet. These are not mere waves from an earthquake, they are the entire world's ocean volume rapidly sloshing to find a new equilibrium based on the planet's new static gravitational geometry. Once this massive, destructive sloshing event subsided, the boundaries between the sea and the dry land would be entirely unrecognizable compared to the present day. Geographic technology experts modeled the appearance of a spin-free Earth after the equatorial bulge fully subsided. Their model revealed that the new geography would feature one giant supercontinent circling the planet along the equator. This immense landmass would divide the world into two enormous, distinct oceans, one covering the entire northern polar region and one covering the entire southern polar region, as the water rushed toward those deep basins. This transformation would mean many places currently considered inland would be underwater, while vast expanses of the current ocean floors near the equator would become dry land. The resulting geographical shift fundamentally redefines what the Earth looks like, turning the existing continental structure into a single equatorial land bridge separating two immense polar seas. The forces driving this water movement stem directly from the underlying gravitational shape. The gravitational potential changes, eliminating the bulge and initiating the mass movement toward the poles. This mass movement would trigger immense waves and seismic activity, confirming that even areas not impacted by the initial 1,000 miles per hour winds would be subject to extreme geological violence. The shift from a rotational equilibrium to a static gravitational equilibrium immediately results in a complete planetary makeover. The cessation of rotation has two related but independent consequences for how the world functions: the subtle change in gravity felt at different latitudes, and the radical, devastating change to the day-night cycle. First, consider how gravity is affected at the equator versus the poles. The Earth's rotation naturally produces centrifugal force, which causes the planet to bulge outward at the equator. This physical distortion slightly reduces the gravitational force felt there compared to the poles. This subtle effect is why water collects around the equator. When rotation stops, the equatorial bulge immediately begins to collapse. This mass redistribution causes the gravitational forces felt across the globe to shift dramatically as the planet seeks a spherical shape dictated by static gravity. The oceans rushing toward the poles illustrate this shift in gravitational pull. Next, the most obvious long-term physical change is the daylight cycle changing to 6 months of daylight and 6 months of darkness. If the Earth no longer spins on its axis, the planet's cycle from day to night would be determined solely by its orbit around the Sun. Since one complete orbit takes 1 full year, the cycle of light and dark would also take 1 year. Consequently, every spot on the globe would experience sunlight for approximately half a year, followed by complete darkness for the other half. This mimics the extreme, prolonged light and dark cycles currently only seen at the planet's north and south poles. For the equatorial regions, the newly exposed land bridge across the middle of the planet, this cycle would be disastrous. During the 6 months of daylight, that side of the planet would face the sun continuously, leading to infernally hot months. The constant solar radiation would cause massive heat buildup. During the 6 months of darkness, the opposite side of the planet would face away from the sun, enduring dark, frigid months far from the direct source of heat. This scenario creates temperature swings far greater than anything experienced today, particularly for areas along the equator. During the long daylight period, the heat would be extreme, while the period of perpetual night would be intensely cold. Even the relatively stable polar regions, which are now deep underwater oceans, would experience seasons, though that they would still be awfully cold overall. These intense and prolonged temperature extremes across the planet would trigger catastrophic climate changes, threatening the survival of nearly all existing life adapted to a 24-hour cycle. The slow, gradual deceleration of the planet would still lead to these exact same, drastically different environments. Beyond the dramatic surface destruction and the extreme climate swings, the loss of planetary rotation poses a significant existential threat to long-term survival due to the eventual decline of Earth's magnetic field. The magnetic field acts as a planetary protective shield. It constantly deflects electrically charged particles streaming from the sun and redirects cosmic rays. This protective action prevents these harmful particles and radiation from reaching the planet's surface and damaging the atmosphere. Without this shield, life would be directly exposed to radiation from space. This magnetic field originates deep within the Earth through a complex process described by the geodynamo theory. According to this theory, the field is generated by the turbulent movement of liquid metals, molten iron and nickel within the planet's outer core. Temperature differences deep inside the outer core create convection currents within this liquid metal. Crucially, Earth's rotation plays a significant role in combining with these convection currents to generate the electric currents necessary for the geodynamo effect. If the planet stops spinning, the overall movement driving the geodynamo would diminish substantially. This would inevitably lead to a gradual weakening of the protective magnetic field. While the surface cataclysm is immediate, the collapse of the magnetic field would take a much longer time, estimated to be thousands to millions of years. Nevertheless, the eventual loss of this shield would be devastating for life. Scientists often point to Mars as an example of a planetary body where magnetic field loss had catastrophic consequences. Some researchers hold that the disappearance of Mars's magnetic field in the planet's distant past contributed directly to that planet becoming uninhabitable. The lack of a magnetic shield exposes the planet to constant cosmic and solar radiation, eroding the atmosphere over time. Therefore, even if some form of life was somehow able to survive the initial inertial event and the subsequent century of climatic shifts, the long-term viability of that life would be highly unlikely without a planetary radiation shield. Rotation is therefore fundamental, not just to daily weather patterns, but to the long-term habitability and preservation of life itself. We must now consider how animals, humans, and infrastructure would be affected, given the immediate and long-term consequences already described. For infrastructure, the prognosis is immediate and certain. Everything would be instantly destroyed. Buildings would be thrown eastward at 1,000 miles per hour near the equator due to inertia. This colossal initial force sets off destructive tsunamis and triggers earthquakes globally. There is essentially no human infrastructure that could withstand this total planetary deceleration. For animals and humans, survival against the inertia effect is highly unlikely. Everything not physically anchored to the stationary ground would be propelled into a low orbit or slammed into whatever stationary object remained. If we imagine a hypothetical, impossible scenario where organisms survived the initial catastrophe, the long-term environmental changes present an impossible challenge. Climatic extremes. Life adapted to a 24-hour day-night cycle cannot easily withstand the new cycle of 6 months of infernal daylight, followed by 6 months of frigid darkness. Impact on crops and food chain. The fate of plant life, which forms the base of the food chain, is uncertain. Could crops survive the extreme prolonged heat followed by the extreme prolonged cold? If conventional crops fail, the entire global food chain would be endangered. Humans would need to find or modify entirely new crops to tolerate this radically different environment. Some researchers suggest only perennials plants that return with warm weather might survive. Resource management. Humans are adaptable, but survival would require powerful technology to heat and light homes during the dark period and cool them during the heat. This technology would be tremendously costly to run and maintain. The ultimate question is, could anything survive long-term? Given that the rotation provides the magnetic field, a shield against harmful space radiation, its eventual loss presents a final, unresolvable threat. If the magnetic field gradually weakens over thousands to millions of years as expected, the Earth's atmosphere and surface would become subject to constant cosmic and solar radiation. This exposure would make long-term survival on the surface highly unlikely. We have been warned that losing a magnetic field contributed to Mars becoming uninhabitable in the past. In summary, the immediate forces of the instantaneous rotation stop and are so catastrophic, inertia, tsunamis, earthquakes, that virtually nothing on the surface could survive the first few minutes. Even if miraculously life was shielded through that phase, the resulting climate swings and the eventual loss of the magnetic shield make long-term viability questionable at best. The essential function of Earth's spin is preservation. When that spin stops, preservation ends. If you want to understand space like a NASA-level analyst, quick without studying for years or paying thousands for a university degree, we have a community that will help you. Link is below. The physical laws governing our planet maintain a delicate balance. The forces unleashed by the cessation of Earth's rotation demonstrate how quickly that balance can turn our familiar home into an unrecognizable and hostile environment. To explore another catastrophic scenario where physics transforms our solar system, click here to watch What If the Sun Was Replaced by a Black Hole video.